These problems we're going to be evaluating the logarithm here. So we're going to come up with a number answer, and we're looking for the power. So you can think of it a couple of different ways. You can think of, okay, 2 to what power gives me back 1 over 8? And it's going to have to be a negative power to get that fraction going, because 2 to the, think about it this way, log base 2 of 8, 2 to the third power gives me back 8. So the answer here would be 3, but 2 to the third isn't going to give me 1/8. To get the 1 over 8, I would need the power to be a negative. That's one way to think of it. Another way is to rewrite 1/8 as 2 to the negative 3 power, and then use our properties from the previous page. Log base 2 of 2 to the negative 3 equals negative 3. If we're allowed to use our calculator, there is kind of a neat way that you can do this as well, and all graphing calculators are capable of doing this. We can change the base. Notice I only have log, log base 10, and natural log on my calculator. So I could take my log base 2 of 1/8 and change the base. I'm going to change it to natural log. This is later on, we'll talk about the change of base formula here. Natural log over natural log. The number in the argument goes on top, and the base goes to the bottom. Now I can use my calculator, and I can type in natural log of 1 divided by 8 over, or divided by, and then natural log of 2. And I get negative 3 as well. I could have changed it to log, but again, I still have to keep the argument on top, and then log, and then the base, log base 10 of 2 will go on the bottom, and I'll still see negative 3. So I can change the base to either natural log or log base 10 and figure out if I've got the answer correct or not. For these, though, you really don't need to do this change of base. This is just a great way to check. So for letter I here, I've got log base 7, and in a previous section we talked about how to rewrite a square root as a fractional exponent. And now that I have log base 7 of 7 to the 1/2, my answer is just 1/2. Of course, you could check it changing the base, and I'll let you do that on your own. Argument on top, base to the bottom, and you should also see that the answer comes up 1/2. I'll probably say 0.5 because it's on your calculator, but you can change a fraction or a decimal back to a fraction by using your math key. All right, this one, this is log base 10 of, and then 1 over 100 is 10 to the negative 2. 10 squared is 100. The 1 over is the negative. So my final answer is just negative 2. And J was a property, log base 9 of 1. We're thinking of 9 to what power gives me back the number 1, and that power would have to be 0. For example 32, these are going to be problems that we're going to be solving for x. So we're going to get x equals, we're going to get an exact answer, and then we're going to convert it to an approximation, rounding to the hundredths place, which means 2 decimals. That's hundredths place. So for the first step, you get the log of the exponent completely by itself, and then convert to either a log or an exponent, depending on what you have. So think about it this way. If I have addition in the problem and I want to get rid of an addition problem, I use subtraction property. Or if I have a subtraction symbol and I want to get rid of it, I use the addition property. Same for multiplication and division. They're sort of opposites of each other, right? They undo each other. Well, a logarithm and an exponent will undo each other as well. So in problem A, we already have the logarithm by itself. So I want to now get rid of a logarithm. I'm going to have to rewrite it as the exponent. So the base is 10, the power 2.45 equals x. This is the exact answer. I've got the x on one side, everything else on the other. If I want the decimal approximation, that's where I've got to go to my calculator and type in 10 and raise it to the 2.45 power. Notice I get a big long decimal, but they only want me to round it to 2 decimal places. So I've got this as the answer, an approximation of it anyway, 281.8382. 9. There were some other digits after that. If I'm rounding to 2 decimal places, right, 1, 2, I draw a line in and I look to the 3rd decimal spot. If it's 5 or higher, then I'm going to round this number up. If it's not 5 or higher, then I stick with the number that I see. So my approximation, kind of the wavy equal sign, is 281.8, and then I'm going to round the 3 up to 0.84. Right. Trying letter D here, the logarithm is not by itself. There's a plus 6 here. So I'm adding 6. The opposite of addition would be subtraction. So I'm going to subtract 6 from both sides of the equation first. Now there's no multiplication or division going on here, so I'm down to, I need to get rid of a logarithm. I'm going to use an exponent. So I start with my base is 3 to the 2 power equals x. Well, 3 squared is easy enough. That's 9. And that's my exact and rounded answer. For letter B, I still see an addition problem here. So I'm going to use the addition-subtraction property to get rid of the number 2. It's positive 2, so I'm going to subtract 2 from both sides of the equation. I have e to the x equals 7. I have an exponent, so again, think about what's the opposite of exponent. That would be the word logarithm. So I'm going to start out log base e of something equals the power. Now another name for log base e, remember, is natural log. And right here is my exact answer. If I need the decimal approximation, I go to my calculator, type in natural log of 7, and round it to 2 decimal places. So again, count 2 decimal places, but between decimal 2 and 3, I'm drawing my line in. To the right of the line is 5, so that means I'm going to round this number 4 up. So my final approximation is going to be 1.95. All right, the decimal or the dot above the equals is also a way of showing approximation. So you can use a wavy equals or the dot above the equals. Here I have an addition problem, so I need to use the addition-subtraction property to get rid of the number 3. Subtract 3 from both sides. Now I want to get rid of a logarithm, so I need an exponent. I need to know what's the base of this logarithm. That becomes the base of this exponent here. So remember, this is really log base e of x equals 4. So my base is e to the 4th equals x. There's my exact. Now I need my approximation. So go to your calculator, E, which is above the ln button, e to the 4th, right, and then round to 2 decimal places. So this is 0.59 with the 8 hanging out there. So it's 8 is bigger than 5, so that's going to round that 9 up. It's going to take it to the number 60 instead of 59. So this is going to be approximately our 50, what was that, 54? Yeah, 0.60. That's my approximation. Right. For this next one, this is now hooked by multiplication. So going back to what unhooks multiplication, that would be division. Divide both sides by 5. 10 to the x equals, and that works out to, should be like 23. Then you need to rewrite, get rid of the exponent and rewrite it as a logarithm. Remember, the opposite of exponent is log, so I'm going to write the word log base 10 of 23 equals the power. Using your calculator, right, I need log. And I don't have to type the base 10 in because my calculator already knows that's base 10. I just type in 23 and I come up with 1.36. The 1 isn't going to bump that up, so it's just about 1.36. And for this last one, I see a subtraction, so I need the addition-subtraction property to get rid of the number 7. It's positive 7, so take away 7 from both sides. Bring down that minus with the word log, because that's really a -1 times log base 10 of x. To get rid of the -1, it's hooked by multiplication. Divide both sides by -1. So I have log base 10 of x equals -2. So 10 to the -2 equals x. All right, and then again, if you feel comfortable or not comfortable with the negative exponent, we need a decimal approximation. You can go ahead, go 10, raise it to the -2, come up with 0.01. And those are your answers.